I've worked in the industry for a number of decades. The interesting thing I find is that the technical challenges that we face today are more complex, basically because there are more things interacting in more different ways than we have ever seen before. Just as an abstraction, imagine you've got a big digger, does a big job. You could replace that, if you so desired, with little diggers. As long as you coordinate them well, everything is going to be good. Unfortunately, if you're uncoordinated, they're going to get in each other's way and there's going to be problems. And the reason I mention this is that with microgrids, you have to be very careful about how you use them, how you apply them, and how they interact. Someone has to know how all electric systems work together so that they don't start to interfere with each other or cause trouble. And it's a safety issue. And if there's one thing I've learned over the years with the electric supply system, you don't mess with electricity. Just as a background on IEEE, I am chair of the working group on asset management. IEEE has lots of standards, lots of guidelines. So top one, standard for testing of microgrid controllers. Next one, standard for specification of controllers. Standard for doing planning and design of microgrids. These are all documents which can be used. They're available. They help identify what is needed. And they are very useful references to make sure that the microgrids that we put together will operate either standalone or islanded mode, as it's called, or in grid-connected mode. The IEC also has a very nice little document from many years ago now on microgrids for disaster recovery and preparedness. It's a very easy read, a lot of information in there. Quite a few of the disasters it talks about are not really microgrid focused, but they do talk about how microgrids would be very useful